Okay, so what we're going to do is go through a few of the simplifying radicals problems and some of the other problems on your review for the trigonometry test. So, first of all, the first four problems are simplifying radicals. And I want to remind you before we get going that there are certain numbers I told you that you can always try that will usually help you find a perfect square factor. I told you to divide by 2, 3, 5, 6, or 7. And those numbers will usually help you find a perfect square factor if you don't catch the factor right off the top of your head. So for number 1, we have the square root of 448. When I try dividing by some of the other numbers, 2, 3, 5, 6, and 7, I realize that 7 gives me a perfect square factor. So when I rewrite this, I'll rewrite it as the square root of 64 times the square root of 7. Now, since 64 is my perfect square, I can simplify that further, and the answer would be 8 times the square root of 7. All right, on number 2, this is a multiplying problem with radicals. And if you remember, I told you you're going to multiply numbers with numbers, radicals with radicals. So this is going to give you 2 times the square root of 12. And I know a lot of you want to leave it there, but don't, because remember, you have to get the largest perfect square that divides into 12. And the largest perfect square that goes evenly into 12 is 4. So I'm going to rewrite this as 2 times the square root of 4 times the square root of 3. Now that can be simplified some more. The square root of 4 is 2, so you're going to have 2 times 2, because this second 2 right here comes from this square root of 4 over here, times the square root of 3. If you multiply this, your final answer will be 4, because 2 times 2 is 4, times the square root of 3. Okay? Now, problem number 3 is a division with radicals. I told you you can divide numbers with numbers and radicals with radicals. But I also told you that if possible, you want to try to reduce your radicals before you have to rationalize them. So I'm looking at this. I have a square root of 10. I have a square root of 15. I know that I can divide 5 into both of these. So 5 goes into that square root of 10 twice. 5 goes into the square root of 15 3 times. So if I rewrite it, I now have the square root of 2 divided by the square root of 3. I can't leave that though, because you know the rule, you cannot leave a radical in the denominator. So what you're going to do is you're going to rationalize. And to rationalize, remember, you're going to multiply whatever radical is in your denominator on the top and on the bottom. So I'll multiply by the square root of 3 over the square root of 3. Now, if I multiply straight across the top and straight across the bottom, on the top I've got the square root of 2 times the square root of 3. That gives me the square root of 6. In the denominator, I have the square root of 3 times the square root of 3, which I know is the square root of 9, but 9 is a perfect square, and the square root of 9 is 3. Now, this is my answer because I can't simplify it anymore. There are no more perfect squares that divide into that 6, and it's okay to have a radical in the numerator. So I am done with number 3. On number 4, again, multiply numbers with numbers, radicals with radicals. So I have 2 radicals, the square root of 5 multiplied by the square root of 6. When I multiply them together, I have the square root of 30. And if I could find a perfect square that divides into the 30, I would, and simplify it further, but there is no perfect square that goes evenly into 30. So this is the final answer. All right. Let me scroll down, and we'll look at number 4 and 5. Well, actually, I think I'm going to pause for a minute. Okay, so I'm going to erase what I have here, and then we're going to do numbers 5 and 6. Okay, for the directions on number 5 and 6, it says for us to solve for x and then round the answer to the nearest tenth. Now, when I look at these two problems, immediately what I see is that I've got a right triangle, and I know the length of two sides of those right triangles. So automatically my mind says, this is a Pythagorean theorem problem. So I'm going to go ahead and use the Pythagorean theorem to solve it. Don't forget, when you do the Pythagorean theorem, the formula is leg squared plus leg squared equals hypotenuse squared. And then if you remember, the legs are the two sides that make the right angle. So this is a leg. This side up here is a leg. And across from your right angle is always going to be your hypotenuse. So now I can substitute in. I'll have x squared plus 4.1 squared equals the hypotenuse squared, which is going to be 11.4. And we got to square it. Now, when you square this, you've got x squared plus, and then 4.1 squared is equal to 16.81. And that's going to equal 11.4 squared, which is 129.96. Now, to get the x squared by itself, I'm going to subtract the 16.81 from both sides. X squared equals, and that's 113.15. Now you know you have to take the square root of both sides to get x. And you end up with x equals 10.6. Okay. Number 6 is going to work the exact same way. So you're going to have 8.6 squared plus 11.2 squared equals x squared. 8.6 squared is 73.96. 11.2 squared is 125.44 equals x squared. Now add the two together. So the 125.44 plus 73.96 equals 199.4 is equal to x squared. Now again, you have to take the square root of both sides. When you take the square root of that, you get 14.1 is the approximate value for x. Okay. For number 7 and number 8, it said find the measure of angle A. Now there are two different ways you can do those two problems. You could add all three angles together and let them equal 180, because remember the three angles of a triangle always add up to 180. Or you can remember that in every single right triangle, your two acute angles are always going to be complementary. That means that angle A here and this angle over here are going to have to add together to equal 90 because they're complementary. So you can set your equation up either way. It doesn't matter. As long as you do it correctly, you'll get the same correct answer. So I'm going to add them and let them equal 90 just because I just want to. So I have x minus 4. X minus 4 plus 64 minus x equals 90. Now, when I combine my like terms, oh, my fault. I'm thinking ahead of myself. It should be x minus 44. Okay, let me try again. X minus 44 plus 64 minus x. Oh, that's plus x. My God, I can't see. Okay, let's try this one last time. On my screen, it looks like a minus and a minus, but there are two pluses. So let's try it one more time. My fault. So this is x plus 44 plus 64 plus x equals 90. That's better. All right, now combine like terms. I've got x plus x, that's going to be 2x, plus 64 plus 44, it's going to be 108, equals 90. Now I want the x by itself, so I'm going to subtract 108 from both sides. So 2x equals 90 minus 108 is a negative 18. And at this point, I'm going to divide both sides by 2. And x equals negative 9. Now the problem is they didn't ask us for x. They asked us for the measure of angle A. So you're not going to leave it at x equals negative 9. You're going to take that x and plug it into the measure of angle A. So let's do that over here. The measure of angle A equals x plus 44. And when you plug in negative 9 plus 44, you find the measure of angle A is 35 degrees. Okay, so question number 8 is going to work exactly the same way. Keep in mind your two acute angles in a right triangle are complementary, so they're going to add together to equal 90. So you'll have 7x plus 2 plus 14x plus 4 equals 90. Now combine like terms. 7x plus 14x is 21x plus 6 equals 90. Subtract 6 from both sides. You get 21x equals 84. And then if I divide both sides by 21, x is equal to 4. And again, x is not what they ask you for. They want the measure of angle A. So you're going to take your angle A and you're going to plug it in. So the measure of angle A is equal to 7 times x, which we know is 4, plus 2. 7 times 4 is 28. 28 plus 2 is 30 degrees. So the measure of angle A is 30 degrees. Okay, so before we start on numbers 9 and 10, I want to refresh your memory on the special right triangles. Remember, you had two different types of special right triangles. We have a 45-45-90 triangle, and then we also had a 30-60-90 triangle. Number 9 and number 10 are the 45-45-90 triangles. And I keep having people ask me, well, Miss T.S., how do you know which one is which? Well, you got to look at the triangles. If you see a 45-degree angle, then you know it's a 45-45-90 triangle. If you see an angle that's either 30 degrees or 60 degrees, you know it's a 30-60-90 triangle. So we're going to talk about the 45-45-90 first, because that's what you're going to need to do number 9 and number 10. So in the 45-45-90 triangle, remember you have your right angle here. The two acute angles are both 45 degrees. And because you've got these two congruent acute angles, then you have to remember that the legs are congruent. If you look back in your packet on the note sheet on the special right triangles, there are a couple things I told you. I said that the two legs in a 45-45-90 triangle are always equal. So this is a leg, this is a leg, and your legs in this type of triangle will always be equal to each other. This is your hypotenuse. Of course, it's across from the right angle. The other thing I told you is the ratio of the sides. Since the two legs are equal, if this side is x, that means this leg is going to be x. And then your hypotenuse is the square root of 2 times the leg, so it's going to be x times the square root of 2. Now there was only one formula that went with this one, and that formula is hypotenuse is equal to the length of the leg multiplied by the square root of 2. Now, if you remember that formula, every time you see the 45-45-90 triangle, you're going to write that formula and you're going to substitute in. So let's go ahead and do number 9 and number 10. All right, so for number 9, the problem says solve for each variable in the special right triangles. Leave your answers as simplified radicals. That means we don't want decimal answers here, so you're not going to be using the calculators to get decimals. So for this number 9, this side is a leg. Hold on a second. This is going to drive me crazy. Well, I may have to just drive me crazy. Okay, this side is a leg, this side is also a leg, and this is your hypotenuse. Now, because we know that the legs in the 45, 45, 90 triangle are congruent, we don't even have to do any work to know what the answer is for y. It's the same as the other leg. It's the square root of 6 divided by 6. No work, just remember that they're the same. Now, for the hypotenuse, you do have to do work, so you're going to start by writing the formula. The hypotenuse is equal to the leg multiplied by the square root of 2. Now, substitute in the picture, we're given that the hypotenuse is x, so we put that here. We're also given that the leg is the square root of 6 divided by 6. And we're going to multiply that times the square root of 2. Now, if you need to, put this square root of 2 over 1. You don't have to, but if you need to, go ahead. It doesn't change anything. Multiply straight across the top. So you have the square root of 12 on the top. And on the bottom, 6 times 1 is 6. Now, a lot of you, I know, want to leave it there, but you can't because there is a perfect square that divides into that 12. So you got to simplify it. The perfect square that goes into 12 is 4. So you're going to rewrite that as the square root of 4 times the square root of 3 divided by 6. Now, the square root of 4 is 2. So you've got 2 times the square root of 3 divided by 6. If you can reduce anything at this point, you have to. So the 2 and the 6 I know can be simplified. So 2 goes into itself once, 2 goes into that 6 3 times. So the answer for this particular problem will be the square root of 3 divided by 3. That's your answer for number 9, for x rather. Okay, now that we've done that one, let's go ahead and do number 10. Here. All right, for number 10, same thing. It's a 45, 45, 90 triangle. This side that was given is our hypotenuse. The other two sides are legs. So write the formula out. Hypotenuse equals leg times the square root of 2. Then you're going to substitute in. Your hypotenuse is 3 square root of 2, so put it here. And the leg can be either x or y. It doesn't matter which one you put because, again, they are congruent. So I'm going to put x times the square root of 2. Now, since I need to get that x by itself, I'm going to divide both sides of the equation by the square root of 2. So when I divide by the square root of 2, these radicals will cancel out. These radicals cancel out as well. And I'm lucky because now I'm done. X is equal to 3. And if you know x is equal to 3, then you also know that y is equal to 3. Because remember, your legs are congruent. Okay, so for this next two problems, number 11 and 12, those are 30, 60, 90 triangles. Remember I said a minute ago, if you're not sure what type of triangle you have, look at the angles that are given. And in number 11, you have a 60-degree angle. In number 12, you have a 30-degree angle. That lets you know that these are 30, 60, 90 triangles. So now, what we're going to do is I'm going to do a quick refresher on the rules for the 30, 60, 90 triangle. And after that, we're going to go ahead and do 11 and 12 using the rules that I'm going to remind you of. So in this 30, 60, 90 triangle, keep in mind that you've got a right angle. Uh-oh, let me go back. Keep in mind that you've got a 90-degree angle here. You're going to have a 30-degree angle, and you're going to have a 60-degree angle. If you remember, your short leg is always directly across from the 30-degree angle. So this is the short leg. Your long leg is always directly across from your 60-degree angle. So the 60-degree angle is here. Draw an arrow. It's going to point you right to the long. So here's your long leg. And then, of course, the hypotenuse is where it's always going to be, which is straight across from your right angle. So there's the hypotenuse. Now, there is a special relationship between these sides and these angles. The ratio for the sides is if the short leg is x, then the long leg is going to be the square root of 3 times the length of the short. So that'll be x times the square root of 3. And then your hypotenuse is double the length of the short leg, so that makes it 2x. Now, there were two formulas that I gave you here. The formulas are hypotenuse is equal to 2 times the length of your short leg, and then the long leg is equal to the short leg times the square root of 3. Okay, for the 30, 60, 90 triangle, the other thing that I need you to remember is that if you are solving for a side or a hypotenuse in the 30, 60, 90 triangle, if they do not give you the short leg, then you have to find the length of the short leg first. So remember, if they give you the short leg, that's good, because that's easy. All you then have to do is plug into the formulas. But if they don't, then you always find that short leg first. Okay, always find it first. Okay, so let's get to the examples for the problem. So number 11, this is a 30, 60, 90 triangle. We know it's a 30, 60, 90 because it's got a 60-degree angle. And then I told you that I want you to label the triangle based on the side lengths. So remember I told you across from the 60-degree angle is going to be your long leg. So this is the long leg. Across from the 30-degree angle is going to be your short leg. So Y is the short leg. And of course the hypotenuse is always across from your right angle. So in this problem, they gave us the long leg first. And if they give me the long leg, then remember you need to find the short. So you're going to start by using the formula for what they gave me. So they gave me the formula for the long, I start with that formula. So long equals short times the square root of 3. And I'm going to say it again. No shortcuts. Write the formula out in words completely, and then substitute in what they've given you from the picture. So from the picture, I see that the long leg is 2. The short leg is Y. We're going to multiply that by the square root of 3. Now I need Y by itself. So since I need to get the Y by itself, I'm going to divide both sides by that square root of 3. Now on the right side, that's good. I have Y. But on the left side, I have a problem. Because if you remember, you cannot leave a radical in the denominator. So this square root of 3 that's left in the denominator is not acceptable. We can't leave it that way because our radical won't be simplified. So what we're going to do is take that 2 divided by the square root of 3, and now we're going to rationalize. And if you remember, when we rationalize, I told you you're going to multiply both the numerator and denominator by whatever radical you have in your denominator in the original problem, which was the square root of 3 up here. Okay. All right, so now, what we're going to do is multiply straight across the top and straight across the bottom. On the top, you're going to have 2 times the square root of 3. And on the bottom, the square root of 3 times the square root of 3 is the square root of 9. But the square root of 9 is equal to 3. So we now know what the length of our short leg is. Y is the short leg, and the length is 2 times the square root of 3 over 3. So now we're not done. We still have to find the hypotenuse. So you write the formula. The hypotenuse is equal to 2 times the short. And since the hypotenuse is 2 times the short, you're going to substitute in. The hypotenuse in the picture is x. We just found the short leg, and that's 2 times the square root of 3 divided by 3. Now remember, you can put this over 1 if you need to. Multiply straight across the top. You have 4 times the square root of 3. And multiplying across the bottom, 1 times 3 is equal to 3. So now we are done with number 11. Number 12, you're going to do pretty much the same way. You label what you have first. After you label what you have, then you decide which formula you're going to use. So in this problem, we get the 30-degree angle, and directly across from it is our short leg. The hypotenuse, again, is always across from your right angle. And the long leg is always opposite the 60-degree angle. Now, in this case, since we're given the short leg, it doesn't matter which one you solve first, because you're going to get the same answer either way. And we've already been given the short leg. So we're going to go ahead and do hypotenuse first. hypotenuse equals 2 times the short. If you plug in, your hypotenuse is A. That equals 2 times the short, which we know is 2 square root of 5. This one's going to be straightforward, just multiply. 2 times 2 square root of 5 will be 4 times the square root of 5. That's A. B is the long leg, so write that formula in words. Long equals the short times the square root of 3, excuse me. When you plug in, the long leg is B. The short leg is 2 times the square root of 5. And we're going to multiply that times the square root of 3. Now, if you remember, I told you you can multiply numbers with numbers and radicals with radicals. So B will equal 2 times the square root of 15. Okay. So now, let's do number 13. All right, number 13 says, each side of an equilateral triangle is 12 inches. Determine the height. And then include a picture. Okay, so I want my triangle to be kind of neat, so let me try to get one up here. Okay, so here's my triangle. For this triangle to be an equilateral triangle, you have to remember certain things. If it's equilateral, that means all the sides are equal. So you can go ahead and mark all the sides as being the same length. And all the angle measures are equal. Well, if all the angles are equal, that means every angle is 60 degrees, because the whole triangle has 180 degrees. Divide that by 3, and each angle will be 60. So 60 degrees here, 60 degrees here, and 60 degrees up here. But this is asking us to find the height of the triangle. So the height of the triangle means what is the distance from the vertex, which is up here, to the side opposite that vertex, which would be this side down at the bottom. So I'm going to draw what's called an altitude in here. An altitude is a segment that comes from the vertex of a triangle and is perpendicular to the opposite side. Perpendicular means that when it gets to the other side, it's going to form a right angle. So now what I have, instead of having a big equilateral triangle where all the angles are 60 degrees, I'm now going to have a 30, 60, 90 triangle. Let me show you why. Because up here, this angle, which was originally 60 degrees, has now been divided into 2 congruent angles. And if it was originally 60 and it's divided in half, then each angle is now 30 degrees. So if you look at this, you've got a 30-degree angle up here at the top, a 60-degree angle down here, and a 90-degree angle over here. I'm going to draw that separately so you can just look at one half of it, which is the 30, 60, 90 triangle we're going to be working with. Okay, so this angle is 30. The 90-degree angle we already have drawn in here, and this is 60. It said each side of the equilateral triangle is 12 inches. So if this side is 12, this side is 12, and the whole side down here is 12, then when I look at my new triangle, why the heck did I write 16 and say 12? Somebody help me out, Lord. Okay, erasing. Sorry about that. Okay. Each side is 12. 12, and then 12 at the bottom. Okay, so over here on this side, this is 12 because this side was 12. So they're the same. Down at the bottom of the triangle, whereas this side originally was 12, the whole thing was 12, this is half of the 12, so this is going to be 6. Now, you can find this, we'll call this x because that's what they want me to find, by using 2 different things. You can either do the 30, 60, 90 formula and let this be your long leg, or you can use the Pythagorean theorem because now you know the length of 2 sides of a right triangle. So I'm going to do it both ways quickly so you can see which one you want to do. Long is equal to the short leg times the square root of 3. If you substitute in, the long leg is x, the short leg is 6, and you multiply that by the square root of 3. So you're done. It's pretty quick. But if you wanted to do it using the Pythagorean theorem, that's fine too. You'll have x squared plus 6 squared equals 12 squared. X squared plus 36 equals 144. Subtract that 36 from both sides. You get x squared equals 108. And then you're going to take the square root. Now, at this point, I know the square root of x squared is x. But this square root of 108 can be simplified. There is a perfect square that goes into 108, and it would be 36, and then 3. So 36 times 3 is 108. Now, if I simplify this, I'll get x equals 6 times the square root of 3. And notice we get the exact same answer, but the Pythagorean theorem just required more work than if we had chosen to use the triangle, the 30, 60, 90 triangle formula. Okay, let's keep it moving. Okay, this one is the same thing we had, so I'm going to delete this. Delete that page. Okay, so here we are on number 14 and 15. 14 and 15, these are your trig problems. And with these trig problems, you got to know your formulas, basically. No shortcuts for that. You just have to know your formulas. So this is pretty simple. They're asking us to find the value of each trig ratio and then give the answer as a reduced fraction and also as a decimal rounded to the nearest 10,000. So for 14, they're asking us for the cosine of angle x. Well, remember the formula for cosine. Cosine is equal to adjacent over hypotenuse. Now you're going to substitute in the cosine of angle x equals. Now from angle x, this is where I am, the adjacent leg is 10. Now I know at this late date, some of you are still like, well, why isn't it the 26? Well, because 26 is your hypotenuse, and your hypotenuse is never your adjacent leg. Okay, so the cosine of x equals adjacent over hypotenuse. This is the adjacent leg to angle x, and that's your hypotenuse. So it'll be 10 over 26. Now, if you can reduce that 10 over 26, you should reduce it. And 10 over 26 reduces to 5 over 13. They also wanted this as a decimal value. And you know to get the decimal, all you're going to do is divide. So you do 5 divided by 13 in your calculator. And then 10,000th means 4 decimal places. Not 1, not 2, not 3, but 4 decimal places. So 0.3846. Okay, and I don't need to round it up anymore because there's a 1 that follows that 6. So these are my answers for number 14. Number 15, very quickly, the tangent of angle A. Excuse me. Remember, tangent is equal to opposite leg divided by the length of the adjacent leg. So if they want the tangent of angle A, the leg opposite angle A is over here, and it's 8. The leg adjacent to angle A is right here, it's 6. This can be reduced, so the tangent of A is going to equal 4/3. And if you need to make this into a decimal, which you do because they asked for that, you're going to do 4 divided by 3 equals 1.3333 because it is to the nearest 10,000, which we now know means 4 decimal places. Okay, so that takes care of 14 and 15. Let's go over here to 16. All right, for number 16, it says for us to solve for x and round our answer to the nearest 10. Well, obviously, we can't use the Pythagorean theorem here because we don't know the length of 2 sides. So we're going to have to use trigonometry. And if you remember, I told you with trig, you want to label what you have in relation to the acute angle first. So my angle is 73, which is this angle right here. So from this angle, the 12 is opposite. because it's straight across from it. If I drew an arrow from that angle, it's going to point to the opposite leg. The adjacent leg is right beside it, which is the x. All right, now since I've labeled opposite and adjacent, I know this is going to require the tangent ratio. So I'll say the tangent of 73 equals opposite over adjacent. Substitute in the tangent of 73 equals opposite, which is 12, over adjacent, which is x. Now, if I need to get x by itself, since the x is in the denominator, I'm going to switch these. And when I switch them, it'll give me x equals 12 divided by the tangent of 73. Now, put that in your calculator. 12 divided by tan 73 equals approximately 3.7, because they say round to the nearest 10. All right, for number 17, if you label what you have from the acute angle, you're going to have x as your opposite leg, and the 16 is your hypotenuse. If you remember, the ratio that includes both opposite and hypotenuse is sine. So you have the sine of 40 equals opposite over hypotenuse. Substitute in the sine of 40 equals opposite, which is x, over hypotenuse, which is 16. Now you're going to cross multiply here. And you have 16 times the sine of 40 is equal to x. Put it in your calculator. And if you multiply 16 times sine of 40, you'll get 10.3. Actually, you get 10.28. But since we're supposed to round to the nearest tenth, we'll make that approximately 10.3. All right, let's keep it moving. Now, for number 18, I'm going to work out number 18 for you very quickly, and then I'll do number 20 quickly, because I want you to try number 19 on your own. Remember, I've given you the answers in class, so make sure you check and see, are you doing it correctly? But anyway, for these problems, and you do need to be very familiar with this for your test, it asks you to state if each triangle is a right triangle. Well, determining whether you have a right triangle is actually pretty easy. All you have to remember is that if a figure is a right triangle, then when you plug into the leg squared plus leg squared equals hypotenuse squared, you're going to get an equal number on both sides of your equation. So the hypotenuse, or the C, if you use A, B, and C, is always the longest side. So this would have to be my hypotenuse if this is a right triangle. So we're going to do 6 squared plus 8 squared, and then we're going to compare it to 13 squared. Now, if I work this out and I end up with the same number on both sides, then I know this is a right triangle. If I don't, then I know I don't have a right triangle. So 36 plus 64, and we're comparing it to 169. 36 plus 64 is 100. Well, 100 clearly does not equal 169, and for that reason, this is not a right triangle. Now, if I had done this and I had gotten 100 on the left side and 100 on the right side, then they'll be equal. That would make a right triangle. Or if I had gotten 169 equals 169, then both sides are equal, then that would be a right triangle. But since they're not exactly the same, I know it's not a right triangle. All right, let's skip over. Just so you know, for number 19, this one, the answer is yes. But you got to do the work and figure it out. So I'll let you work it, but just know that the answer for number 19 is yes, it is a right triangle. Number 20, for this one, same thing. The longest side has to be your hypotenuse or your C. And I know some people would think, well, wait a minute, the square root of 21, is it bigger than 11? The answer is no. If you put it in the calculator, the square root of 21 is right in between 4 and 5, so it's definitely not bigger than 11. So this is going to be the side that would be the hypotenuse if this is indeed a right triangle. So let's do our work. We have 10 squared plus the square root of 21 squared, and we're going to compare that to 11 squared. I'm sorry, yeah, 11 squared. So 10 squared is 100. The square root of 21 squared is 21. And we're comparing that to 11 squared, which is 121. If I add this, I have 121 equals 121. So yes, this is a right triangle. Okay. All right, quick explanation for number 21. They're telling you that in this baseball diamond, which is also the shape of a square, the distance between first base and third base is approximately 127 feet. And we want to determine the distance between the first base and the second base. All right, so here's some background information for my babies that are not sports fans. In baseball, this is home base. And when they run along this way to first base. This is second base. This is third base. So what they're saying in this problem is that I have this square, and in this square, the distance between first base and third base is approximately 127 feet. So the distance from first to third is 127 feet. Now, I want you to look at this, because if this is a square, you know this is a right angle right here. You know that if it's a square, this diagonal right here is going to divide those angles, those 90-degree angles, into two 45-degree angles. So this angle will be 45 degrees, and this angle over here is also 45 degrees. So what we have now, we started out with a square, but when we divide it in half by drawing that diagonal from first base to third base, we actually have a 45, 45, 90 triangle, and the hypotenuse is at 127 feet. Let me sketch it over here. It's not perfect, but pretend that it is and work with me. All right, so this is 127 feet, first base, third base, home base. And they're asking us, what is the distance from first base to second base? Well, if this is a square, the distance from first base to second base is going to be the exact same thing as the distance from first to home, from home to third, or even from second to third. Every side in a square is equal, so it doesn't really matter which side length you find, as long as you know that they're all the same. So I'm going to start off, since this is a 45, 45, 90 triangle, and I've been given the hypotenuse. The formula is hypotenuse is equal to the leg times the square root of 2. So you're going to substitute in this picture. We know this is the hypotenuse, and we know the legs are the same, so it doesn't matter which one you're thinking about finding, they're all equal. So 127 is your hypotenuse. That equals the leg times the square root of 2. Now, you know if you want the leg by itself, you're going to need to divide both sides of this equation by the square root of 2. So dividing by the square root of 2 here and over here. On this side, it works nicely because the radicals cancel, and that gives me my leg. But on the left side, you got a little issue. Remember, you cannot leave a radical in the denominator, ever. So when you have a radical left in the denominator like here, you know you're going to need to rationalize it. So you're going to have 127 divided by the square root of 2, and then we're going to multiply that by the square root of 2 over the square root of 2, because we have to rationalize. So if you multiply straight across the top, you get 127 times the square root of 2, And on the bottom, the square root of 2 times the square root of 2 is the square root of 4, which we know is 2. Now, if I could have divided the 127 divided by 2 and it had given me a nice even number, I would divide it out. But since it doesn't, I'm going to leave it exactly as it is. And this is my answer. Okay, so we're going to start with number 22. The directions ask us to find each trig value and give your answers in exact form. Exact form means that you're giving the answers with radicals in their simplest form. No, don't make them into decimals. So for this one, they want us to find the cosine of angle theta. Well, if you remember, the formula for cosine is equal to adjacent divided by the length of your hypotenuse. But in this particular problem, this is the angle theta that they're asking us about. This would be the adjacent leg, and I don't know that length. This is the hypotenuse. Since I don't know the length of the adjacent leg, then I need to find it. Now, what do you need to do to find the length of the adjacent leg in this triangle? I'm listening. Y'all can talk to me. What are we going to do? I need to find the length of this adjacent leg so I can do what the question is asking. But what am I going to have to do to find the length of that leg? What am I using to find the length? Nope, can't do trig. I don't know any angle measures. What am I going to do? This is a Pythagorean theorem problem. So you're going to do the Pythagorean theorem first to find the length of the adjacent leg. Once you know the adjacent leg, you'll put it back in the picture here, and then you can use it to find the cosine of the angle like they want. So for the Pythagorean theorem, it's going to be, we'll call this x squared plus 20 squared equals 25 squared. Okay, so we got x squared plus 20 squared equals 25 squared. That'll be x squared plus 400 equals 625. Now I need to get the x by itself, so I'm going to subtract 400 from both sides. So x squared equals 225. And then if you take the square root of both sides, you'll get x equals 15. Okay, so now we know x is equal to 15. We're going to take that 15 and put it in the picture. Okay, so x is equal to 15. We put the 15 in the picture. Now I can find the cosine. So the cosine of angle theta is equal to adjacent. What's the length of the adjacent leg now? It's 15 over hypotenuse. What's the hypotenuse? What's the length of the hypotenuse? 25. So cosine of theta equals 15 over 25. Now, if you can reduce that fraction, you should reduce the fraction. What can go into both 15 and 25? 5. So this would reduce to cosine theta equals 15 divided by 5 is 3. 25 divided by 5 is 5. So that's your answer here.
So you don't put decimals?
No, they didn't ask for decimals because they wanted as exact. They said give exact answers, and that means we're not getting decimals. We want either a fraction or a radical in its simplest form. Okay, so I'm going to skip number 23 because everything you need to do 23 is given. The only thing that you have to remember on that one is when you set this up, you're going to end up with the radical in the denominator. Don't forget to rationalize it out. Okay? I'm going to do number 24. All right, for number 24, it says, find the tangent of angle theta if the cosine of theta is equal to 8 over 17. All right, so I'm going to draw a right triangle first. And I'm going to call one of those angles theta. It doesn't matter which one of the acute angles you call theta. And then you got to remember what your formula is. Remember, the formula for cosine is equal to adjacent over hypotenuse. So what they're telling me is that from this angle, the adjacent leg and the hypotenuse would give me a ratio of 8 over 17. So what is the leg? Well, let me go here. The leg that's adjacent to this angle theta is right here. That length is going to be 8 because up here the formula cosine of theta equals 8 over 17 tells me the adjacent leg is 8 and the hypotenuse is 17. So put 17 here for your hypotenuse. So all you're doing is using the formula that they're given to work backwards and fill in the triangle. But now they want the tangent of theta. Well, you know tangent is equal to opposite over adjacent. And of course, when you look at the triangle, the opposite leg is not given. So we're going to have to find it. We'll call that x. This problem is now going to be just like the one we did in number 22. We have to find x. What are you going to use to find x?
10.
What did we use up here in number 22? It's a Pythagorean theorem problem. So you're going to use Pythagorean theorem down here to find x. I don't know how many times to tell you, but when you are trying to find a missing leg or a side in a right triangle, if you know the length of two sides, you always use Pythagorean theorem to find the third one.
So it'll be x squared
Hold on 1 second. All right, x squared
x squared plus 8 squared equals 17 squared.
Okay, so x squared plus 8 squared equals 17 squared. Now work it out. That'll be x squared plus 64 equals 289. Now I need to get x by itself, so what am I going to do?
Move 64 over.
All right, subtract the 64, so x squared equals 225. Now take the square root of both sides. So you get x equals 15. So you can take that 15 and put it in the picture. Now that we know this opposite leg is 15, we can go ahead and find the tangent of theta. So the tangent is opposite over adjacent. What is the length of the leg opposite this angle? This is the angle. What's the leg opposite that angle?
X.
15.
It's 15. And the adjacent leg is 8.
Really keep it like that.
Now that 15 over 8 cannot be reduced because nothing can divide into both 15 and 8 evenly other than 1. So we leave it exactly how it is.
You need to be 25.
I will help you set up the triangle for 25, but I won't work it all the way because I want you to practice it. Let me give you the answer to it though. For number 25, the answer is the square root of 2 over 4. So that's what your answer will be for 25, the square root of 2 over 4. All right, so when you're done, that's what you should have. But we can set it up, make your right triangle. Oh, I'm just telling you in advance, that's the answer.
Oh.
Yeah.
Oh.
All right, so I'm going to call this my angle theta again. And the problem tells us that the sine of theta is equal to 1/3. Well, if the sine of theta is 1/3, sine is equal to opposite over hypotenuse. So they're telling you in this part up here that the length of the leg opposite this angle is 1. So from this angle, go across. This is the opposite leg, it's 1. This tells me that my hypotenuse is 3. So what are you going to do to get that third leg?
You gotta find the x, right?
Right, well, how are you going to get the x?
But,
All right, do the Pythagorean theorem.
x.
I'm not going to do it with you because I know you can do it on your own. Just remember, do the Pythagorean theorem. That's going to give you x. And then once you get x, put it in your picture and use that to find the tangent of theta, which is what they're asking for. No, you can put the angle either at either of the acute angles in the triangle. The question was, do you always have to put the angle theta in the right bottom corner, which is where I put mine? But no, you can put it up here at the top or down at the bottom. It doesn't matter. It won't change anything as long as you set everything up correctly. So if I had put my angle up here, and then I said sine is still opposite over hypotenuse, just the 1 would be down here, and the 3 would be over here. You do the Pythagorean theorem just like normal. Okay. All Okay, so for number 26 and 27, the directions ask us to find the measure of each angle indicated and then round our answers to the nearest degree. So start off just like normal, labeling what you have in relation to the angle. So this is my angle. In relation to this angle, this 4 is my adjacent leg, and 5 is the hypotenuse. So if I have adjacent and hypotenuse, what ratio is that? That is cosine. So you're going to say the cosine of your angle, which is theta, equals adjacent divided by hypotenuse. The cosine of theta equals the adjacent leg is 4 and the hypotenuse is 5. Now, since they're asking us to find the measure of an angle, what do you know you have to use? You have to use the inverse. So on your calculator, you're going to do second cosine. And that's going to look like this. 4 divided by 5 equals theta. You don't flip them, you just move this over and then that over. That's all. You flip, you switch, is that what you mean? When you're finding, you switch when you're finding the length of a side if your variable is in the denominator. Remember, if your x is on the bottom, then you switch them and then you divide. But in this case, we're doing an angle, so you do inverse cosine of 4 divided by 5 equals theta. Now, if you put that in the calculator, what is the inverse cosine of 4? I'm sorry, what is it? Okay, so if it's 36.9, they told us to round this to the nearest degree. What are you going to round that to?
40. I mean, not 40, but 37.
Exactly. This will be approximately 37 degrees.
Wait, if it's 36.86, you round the 8 to a 9, right?
If it's 36.8 anything, because they want us to round it to the nearest degree, that means the nearest whole number. So if it says 36.8, that's 37 degrees.
Well, yeah, it says 36.
Yeah, so round it up to the next number. Okay, that's the answer, 37 degrees is the approximate answer for X. Now, for number 27, that one is going to work exactly the same way. So I'm not going to work number 27 for you, but I will tell you the answer. The answer for number 27, the angle is approximately 65 degrees. Okay, so practice it and check and make sure you get 65. Okay, for number 28 and 29, those work exactly the same as well. The answer for number 28, yeah, number 28, the answer is 25 degrees. And number 29 is 27 degrees. Okay, I want to do one like number 30. Now, for number 30, it says solve each triangle and round your answers to the nearest tenth. When you are asked to solve a triangle, I told you before, that means that you're going to basically find everything they did not give you. So if they give you 2 sides and 1 angle, then you're going to be finding everything else. In this case, they gave us 2 sides, segment BC and segment AB, and they gave us the measure of angle C. But that means we still have 3 things we need to find. What do I need to find?
Your hypotenuse.
Okay, they gave me hypotenuse.
Your
I need the length of segment AC. What else? What else do I need?
Angle B.
I need the measure of angle B and
Measure A.
the measure of angle A. All right, so those are the 3 things that I'm going to need to find. And it doesn't matter to me which thing you find first as long as you find everything. So what do you want to find first? All right, let's find AC. Now, if I'm finding AC, what am I going to use? Thank you, Pythagorean theorem. Now, it is a Pythagorean theorem problem because it's a right triangle and you know the lengths of 2 sides. Since I know these 2 sides, I can find AC by plugging into the formula. So remember, the formula is leg squared plus leg squared equals hypotenuse squared. So when I plug in, my first leg is AC. That's the one I want to find. So AC squared plus 6 squared equals the hypotenuse squared. Alright, so AC squared plus 36 equals, can someone do 137, I'm sorry, 13.7 squared for me? 180, okay, 187.69. Now, I want the AC by itself. What do I have to do? Alright, subtract 36. So AC squared equals 151.69. What do I do now? Okay, take the square root. So the square root of AC squared is equal to the square root of 151.69. Okay, now when I take the square root of this, I get AC, and the square root of 151.69 is what? Now this is approximate, because we do round a little bit, so make that approximate. So I know AC is 12.3. All right, so now, what do you want to find next, A or B? Okay, we'll find angle A. Okay. Is that what you said? Oh, well, I can do B, not a problem. I can multitask and find different things. All right, so we're going to find the measure of angle B. So we're going to do the same thing we did in those problems from number 20 through 29. We're going to do an angle. So you start off with the angle, which is angle B, and label what you have from there. So what is this 6 in relation to that angle?
Adjacent.
Okay, so label, that's adjacent. And what is the 13.7?
The hypotenuse.
Good. Now, if I have adjacent and hypotenuse, which ratio is that?
Sine.
Mm.
Sine.
Adjacent hypotenuse is
Oh, no.
cosine. Remember, SOHCAHTOA, C-A-H. So that's cosine is adjacent over hypotenuse. So cosine of angle B equals adjacent over hypotenuse. Now, if I plug in, the cosine of angle B equals adjacent, which is 6, over hypotenuse, which is 13.7. Now, since we want to find an angle, what are we going to have to do? Good, we do the inverse. So inverse cosine of 6 divided by 13.7 equals angle B. Okay, what does that equal? 64? Okay, so 64 degrees. What, 64 point what?
0, 2.
Okay, good, so we'll leave it right there. 64.0 is the approximate value for angle B. Now, the last thing we need is to find angle A. That's not a problem. How do we find the measure of angle A? Okay, we're going to do the measure of angle A equals 90 minus 64. Here. That's what you get the idea. The measure of angle A is 26 degrees. Okay. Any questions on that? Yes, it only works for right triangles. And it makes sense because the only type of triangle that has a hypotenuse is a right triangle. So you can't use Pythagorean theorem if it's not a right triangle. Okay, so for this problem, you still are being asked to solve the triangle, which means you got to find everything they didn't give us. So tell me, what do I have to find? All right, I need the length of AC. What else?
Your hypotenuse. AB.
All right, AB, which is the hypotenuse. What else?
Measure.
And the measure of angle A. Okay, so those are the three things that were not given that I now have to find. Okay, so what do you want to find first? Good. Let's find the measure of angle. Measure of angle A. Okay, so if I'm finding the measure of angle A, it's real simple. What am I going to do? All right, the measure of angle A equals 90 minus 69. So the measure of angle A equals what?
26.
Ooh, let's try that again.
I got you. Hold on. 90 minus 21.
All right,
It's
so
21. You're late.
thank you. The measure of angle A is 21 degrees. Okay, so now that we've got the angle, we can now find the sides. Which side do you want to do first? Okay, we'll do AC. All right, so to find AC, we're going to label what we have and then decide what ratio to use. So from this angle, what is AC?
Opposite.
And what is the 11.2?
Adjacent.
Okay, so if I have opposite and adjacent, what ratio is it? That's tangent. All right, make sure you know these formulas by heart. So the tangent of 69 equals opposite over adjacent. And then we're going to plug in. The tangent of 69 equals opposite, which is segment AC, over adjacent, which is 11.2. What do we do?
Multiply 69 times 11.2.
Okay, you mean tangent 69?
Yeah.
Okay, so you're going to cross multiply. You're going to multiply that 11.2 times the tangent of 69 equals AC. Now put that in the calculator. What do you get? 11.2 times the tangent of 69.
Is it 29?
It's 29.2. Okay, is there someone who got something different? Okay, hang on. Okay, so AC is 29.2, and now we need to find AB. So what are we going to do to find AB?
That's the hypotenuse.
Right, AB is the hypotenuse. So now we've got the adjacent over here, and the hypotenuse is what we want to find. What ratio uses adjacent and hypotenuse? Cosine. All right, so we're going to find AB. So we said we had adjacent and hypotenuse, so that's cosine. So the cosine of 69 is,
Why did you use hypotenuse and adjacent? I mean, yeah. Why didn't you use the opposite?
oh, you mean why didn't I use opposite and adjacent? I could. You just found that the opposite leg over here is 29.2. So if you had put the 29.2 in the picture, you could use opposite and adjacent and do tangent. Or, I'm sorry, not tangent. You could have done opposite and hypotenuse, or you can do adjacent and hypotenuse. It doesn't matter. You should get the same answer either way. The only reason I choose not to use what I found on my own is because if I did AC wrong, and then I plugged it in up here and use it in the next part, then that's going to be wrong too. So I almost always try to use what they originally gave me when I'm trying to solve something. All right, so cosine 69 equals adjacent over hypotenuse. Substitute in. Cosine 69 equals adjacent, which is 11.2, over hypotenuse, which is AB, and that's what we want to find. Okay, so this is basically one of those problems that we did before where your variable is in the denominator. What are you going to do? We're going to switch them. So when we switch, we're going to have AB equals 11.2 divided by the cosine of 69. Now you divide that out, put it in the calculator. And if you do 11.2 divided by cosine 69, what do you get? Okay, so if it's 31.25, we'll round it to 31.3. Okay. Okay. All right, so now for number 32 and number 33, those you're going to find on your own. Is anyone still copying this? All right, I'll put the answers up here for those, but you are going to need to practice them, so I'm not going to work them all the way out. Okay. So for number 32, the measure of angle A is going to equal 26. The measure of angle B will be 64. And the missing side, segment BC, is approximately 4.4. Okay. Over here for number 33, the measure of angle B is 74. And what is this? Segment BC is approximately 0.6. And segment AC is going to be 1.9. Okay, so those are your answers. When you do it on your own, you can check your work and make sure you do it right. Okay, these. Remember what we did, the trigonometry of complementary angles? You'll find that page in your packet. Trigonometry of complementary angles. We said if two angles are complementary, that means that they are going to add together to equal 90. Then the sine of A, let me write it down. If angle A and B are complementary, then you should know that the sine of A is equal to the cosine of B, and the cosine of A is going to equal the sine of angle B. So they just reverse each other. And if you remember when we did it with numbers, we subtract the number or the angle from 90 degrees and then just switch sine and cosine. So for number 34A, the sine of 32 degrees is equal to the cosine of 90 minus 32, which is what? 58. So don't forget.
90 minus sine of 32.
You do whatever this is, you do 90 minus that angle, which is 32. 90 minus 32 is 58. So the sine of 32 is equal to the cosine of 58. All right, so on this one, the cosine of 10 is equal to the sine of what?
80.
The sine of 80.
Oh.
Whatever this angle is, subtract it from 90. So the angle is 10, so 90 minus 10 is 80. So the cosine of 10 is going to equal the sine of 90 minus 10, which is 80. All right, for part C, and we had examples like this in your notes the other day. Don't get tricked because you see an X in there. The sine of 2x is equal to the cosine of what? Thank you. 90 minus 2x.
I was going to say 88.
Mm-hmm. Don't, because there's an x in there. Not 90 minus 2, it's 90 minus 2x. So the sine of 2x is equal to the cosine of 90 minus 2x. And make sure you put that 90 minus 2x in parentheses just like I did. Now this one is new. This is not something we usually do in geometry. You'll see it in algebra 2 maybe, or definitely if you take trig. The sine of angle A divided by the cosine of angle A is equal to the tangent of angle A. The sine function divided by a cosine function is equal to tangent. It's just one of those, it's called a trig identity. And it's, like I said, it's not something we normally do in geometry. I don't think so. I don't think so. I don't remember every single problem that's on the test, but I'm pretty certain this part is not. Okay, any questions on this before we go to the next part? Okay, for number 35. For number 35, the question is for us to find the area of the triangle. Now, for the most part, we've not done a problem yet where you had to find the area of a triangle, but finding the area of a triangle is a skill that you're supposed to already have when you come here. So we'll start with just the basics, and the basics is the formula for area of a triangle is 1/2 base times height. So if I need to find the area for this triangle, I need to know the height, which is going to be this segment in the middle. That's your height. And then this length down here is going to be the base. The problem is you need to figure out the length of the base. So you're going to have to do a little side work to find out what this length is right here. Okay? So we're going to start by breaking this triangle up into two separate triangles. So I'm going to do the big triangle first. Okay, so in the big triangle, if I break it up, I got the length of two sides. I need to find the length of that third side, which is the height. So what am I going to be able to use to find that length? That is a Pythagorean theorem problem. You have a right triangle, you know the length of two sides, that's the Pythagorean theorem. So you're going to have h squared plus 9 squared equals 10 squared. If you substitute in h squared plus 81 equals 100. Now I want h by itself, so what do I have to do?
Subtract 81.
So h squared is equal to 19. Now what do I have to do next?
What's the radical? With the radical on there.
Take the square root.
Yeah, see?
So the square root of h squared is equal to the square root of 19. Now this is going to be a decimal. It's between 4 and 5, so h is approximately what? 4 point what?
1.5.
Did you put it in there or did you just guess it?
Yes, well,
Okay, come on, tell me exactly.
4.35.
Okay, so it's approximately 4.35. That's going to be the height for the triangle. Now, I need to find this little piece right here because I need that to help me find the length of the entire base. So I'm going to work with this small triangle. I'm going to break it up. Right angle here. We just found that this length is h, and we just found that h is equal to 4.35. This length down at the bottom we're going to call x, and this is 5. So this is still a Pythagorean theorem problem because I got a right triangle and I know the length of two sides. So to solve for x, we'll have x squared plus 4.35 squared is equal to 5 squared. Now hopefully everybody realizes that that 5 is your hypotenuse because it's straight across from your right angle. All right, so I need some help. What's 4.35 squared? Oh, I know, it's 19.
all right.
We just did it up here. 5 squared is 25. What am I going to do now?
Subtract 19, 25.
All right, so when I subtract 19, I have x squared equals 6. Take the square root.
2.4.
All right, so x is approximately 2.4. Now that I know all of that, I can find the area of the triangle. I'm actually going to say it might have been easier for me to leave my answers as radicals. It definitely would have been easier to leave it as radicals, but it's okay. So now let's find the area. The formula for area of a triangle we said over here is area equals 1/2 base times height. Well, take it back. Let me do this first. This x is about 2.4. That goes here. The x is approximately 2.4. If I put that back in this picture, 9 plus 2.4 is the length of the entire base. What is the length of the base?
11.4.
All right, so 11.4 is the length of the base. We found the height a little while ago is 4.35. So if I plug in area equals 1/2 base times height. All right, base is this entire side here, so it's 11.4. The height we found over here is 4.35. Now you multiply it out. 1/2 or 0.5 multiply times 11.4 and then multiply that times 4.35.
So it's 1/2 the base or?
It doesn't matter. It's 1/2 of the whole thing. It's 1/2
So
times
base-
4.35 times 11.4.
So it's gonna be base times height divided by 2.
It's the same thing.
I got it.
So then,
Can somebody just tell me what the answer is?
I got it.
What is it?
24.795.
I'm sorry, repeat that for me.
24.795.
somebody still on my way.
Okay, that's your answer. All right, for number 36, they're asking you to label the angles and the formulas for the sides of the two special right triangles. Now, in your review, you actually already have the special right triangle formulas start with number 9, and they're also going to go through number 13. So numbers 9 through 13 are special right triangle formulas. If you're watching the video and you hear this, I've already explained in detail the 30, 60, 90 triangle and the formulas, as well as the 45, 45, 90 triangles and the formulas. But if you're sitting here in class now, I'll go through it again really quickly. Just know that if you get home and you need to see it again, there is a video explanation again before number 9 and in between number before number 9 and also before number 11 and 12. So for this triangle, this would be most likely your 45, 45, 90 triangle. Remember that it's also called an isosceles right triangle because it's a right triangle and you're going to have two congruent sides. That's why it's isosceles. So these legs are equal. Yes. Don't go by the picture. Go by what is in the picture. Okay? So these are your two legs, and this is your hypotenuse. So if you remember, I told you the ratio of the sides for the 45, 45, 90 triangle would be x, x, and then x times the square root of 2. But from that formula, there is only one, from that triangle, there's only one formula for this particular triangle. And that formula is hypotenuse is equal to the length of the leg multiplied by the square root of 2. So anytime you have a problem that's a 45, 45, 90 triangle, whether you're trying to find the hypotenuse or even if you're trying to find a leg, write the formula out in words first, then substitute in what they've given you, and you'll see what you need to do to find what they're asking you to find. So that's the first special right triangle. Then we got this one. This is going to be our 30, 60, 90. So that's 30 degrees, that's 60 degrees. Now, if you remember, I told you that in the 30, 60, 90 triangle, you've got two legs. One leg is the long leg, one is the short, and then you have your hypotenuse. The short leg is always across from what?
30.
The 30-degree angle. So if this is the 30, this will be my short leg. This is the what?
Long.
And this is the hypotenuse. Good. All right, so we got the long leg, the short leg, and the hypotenuse. I also told you, and you should have it in your notes if you've taken good notes, but I also told you that there's a relationship between those sides. So if the length of your short leg is x, the hypotenuse is 2 times that. So that's going to be 2x. Your long leg is the square root of 3 times the length of the short. So it's going to be x times square root of 3. So that is going to give you the ratio for your sides. But if you need a formula, there were 2 different formulas for this. The first one will be hypotenuse is equal to 2 times the short leg. And then the second one is the long leg is equal to the short leg multiplied by the square root of 3. So those are the 2 formulas that you have for the 30, 60, 90 triangle. Any questions before we go to the next piece?
Are we gonna have to do this part we touch like actually?
I don't think you actually have to write this stuff out, but you do need these formulas to solve problems. There are special right triangle formula problems on the test. So these 3 formulas you need to know, and you should know them by now because we actually had this quiz before Thanksgiving. So if you don't know them, commit them to memory before you take that test. All right, so going to the next one. All right, so for number 37, it says draw the diagonal of the square and label the angles of the 2 special right triangles that are formed. So if this is a square, what do you know about the angles?
Yeah.
And if they're all the same, how many degrees are they?
45.
They're all 90. If it's a square, all of the angles are 90 degrees. But if I draw, well, let me go back. What do you know about the sides of the square?
Equals to.
They're all congruent. So every single side is going to be the exact same length. But then they ask the question. They want us to draw a diagonal. So if I draw a diagonal in here, a diagonal goes from one vertex to the opposite vertex. What kind of triangle does this make?
2 right.
It is 2 right triangles, but what type of right triangle?
45,
2 45, 45, 90s. Now, how do we know it's 45?
because you could divide 90 into, that's 45.
Exactly, because you got a right angle here, and if you got a right angle here, and then if it's bisected by the diagonal, this is going to become a 45-degree angle. This up here will become a 45-degree angle. So you really have, if I highlight it in another color, let me find it. If you highlight it, this is now a 45, 45, 90 triangle. You've got 2 congruent sides, and we know that because in a 45, 45, 90, remember your legs are always equal. So this leg is equal to this leg, and this would become your hypotenuse because it is still directly across from that right angle. And the same thing is true with the other triangle on the opposite side. This angle will be 45, this angle is 45, this angle is obviously 90. Okay? Now, the question was, what is each side length if the diagonal of the square is 12? Okay. This is the diagonal. If this is 12, what would be the length of those sides? What do I have to start off by doing?
Would that be the hypotenuse equals less than square root of 2?
Exactly. Write your formula. This is the 45, 45, 90. You only have one formula. Hypotenuse equals leg times the square root of 2. If you plug in, the hypotenuse is 12. The legs, we don't know what they are, but we know they're the same, times the square root of 2. Now, what do you have to do if you want to find the length of that leg? Divide by? All right, divide both sides by square root of 2. All right, so we have 12 equals the length of the leg times the square. So we're going to divide both sides of this equation by the square root of 2. On the right side, the radicals cancel out, which leaves you with the length of the leg. But on the left side, we have a problem. Because remember, you cannot leave a radical in your denominator. So what are you going to have to do to get rid of the radical in the denominator? What's it called?
Rationalizing.
It's rationalizing. We're going to rationalize this. So to rationalize, we're going to multiply both sides of this numerator and denominator by the square root of 2. Now, if I multiply straight across the top, straight across the bottom, on the top I'll have 12 times the square root of 2. And on the bottom, the square root of 2 times the square root of 2 is the square root of 4. But what is the square root of 4?
2.
4.
It's 2. So I have 12 times the square root of 2 over 2. Can that be simplified any further?
Yes.
Yeah.
Yes. This 2 goes into itself once, and it goes into that 12 6 times. So my final answer is 6 times the square root of 2 equals the length of the leg. Okay? All right, so I'm gonna go to the next one. Is anyone still copying this one? All right, tell me when you're ready. And make sure you remember how to do this one. Chances are you'll see something very similar to this. All right, going over to number 38. All right, for number 38, the problem says draw the altitude of the equilateral triangle and label the angles of the two special right triangles that are formed. Okay, so if this is a equilateral triangle, what do you know about the sides?
They're all the same.
They're all congruent.
Okay. All of them are the same. What do you know about the angles if this is equilateral?
They're all the same.
But what are they going to be if they're all the same?
I forgot the other thing.
What's the measure of each one?
The same.
All right, back up a minute.
How is it?
How many degrees are in every triangle?
180.
180.
180. How many angles do we have? 180 divided by 3 is 60. So all of these angles will be 60 degrees. Okay, so this is a basic equilateral triangle. But they said draw an altitude in there. Well, an altitude is a segment that goes from the vertex of an angle and is perpendicular to the opposite side. So I'm going to draw the altitude right here. And since it's perpendicular to the opposite side, it's going to make a right angle down there. Now, what do you think happened to this angle up here at the top whenever it divides it in half? It's bisected. So this angle is now 30 degrees. The angle over here is now 30 degrees. So instead of having the equilateral triangle, we just divided it and made two 30, 60, 90 triangles. So if I separate it, this is 60 degrees, this is your 90-degree angle, and this is your 30-degree angle. Now, this question says, what is the length of the altitude if each side of the triangle is 6 feet? Well, if this is 6 feet, this whole side down here is 6 feet, this whole side is 6 feet. Come back over here, and let's fill in. What's this length going to be on the triangle?
6.
This will be 6 feet as well. The altitude bisects the angle up here at the top, and it bisects the side at the bottom. What's the length of the side over here now? This will be 3. This will be your altitude, and that's what they're asking. What is the height of it? We'll call that h. Now, first of all, it's a 30, 60, 90 triangle. So you can find this length using the 30, 60, 90 triangle formulas, but it's also a right triangle, and you have the length of two sides. So what else can you use? You could also use the Pythagorean theorem. I can do it both ways, but there's actually another problem in here where I do it both ways. Question number 13. is just like this one, so I'm only gonna do the special right triangle formula here. But for number 13, you can see how you can do it with the Pythagorean theorem and also using the special right triangle. But what leg is this in the 30, 60, 90 triangle? That is not my quadrant.
That's a long leg.
That's your long leg because it's directly across from your 60-degree angle. What is this?
Short.
And what is this? Okay, so I need to find my long leg. Start with the formula for the long leg. That formula is long is equal to short times what? Times the square root of 3. So the long leg is equal to the short leg times the square root of 3. Now you're going to substitute in here. What is the long leg in the picture?
H.
It's h, so that's your altitude. What's the length of the short leg?
3.
And you're going to multiply that times the square root of 3. So there's your answer. The altitude of this triangle would be 3 times the square root of 3. All right. Oh, that's it. We're done with that, huh? Cool. All right. All right. Hopefully, this was helpful. Make sure that to prepare for your test, you make sure you go back and review the word problems. In the trigonometry, you definitely have some of those. Make sure you remember the formulas for the 30, 60, 90 triangle, the 45, 45, 90 triangle, and your trig ratios. All of that's going to show up on your test. Good luck.